Hey everyone, and welcome to the post-test 2 video and notes for Geometry 2019. You should have a calculator and you should also have your notes sheet. We're going to start on the front of it where it says your name. If you could please locate those items, that'd be great. In this video, we're going to be doing two different things. The first thing that we're going to talk about is simplifying a radical, where we split it apart, okay? And the second thing we're going to talk about is if we have a right triangle, there's a very important theorem that we can use to solve that. So this is meant to be review from previous things you've done, all right? First, we're going to start off with simplifying a radical, which you did last year in Algebra 1. There's two ways of doing it. I'd love to show you how to check it on your calculator to make sure that you knew how to do it right. But the big idea is if I can split this up into two numbers and I want one of the numbers to be a perfect square. What's a perfect square, you ask? Well, any number times itself is a perfect square. If we used our calculator, we could go y equals x squared to figure that out. Okay, so if I'm looking at 18, the perfect square that goes into it is 9, and it goes into it 2 times. And the way that we're simplifying it is the square root of 9 gives me 3 radical 2. Okay, so in Algebra 1, we started doing this. In Geometry, we'll be doing it again. You'll also be using this in Algebra 2. If you go to your calculator and you type in the square root of 18, that's not the square root of 18. Try that again. The square root of 18, it gives us a decimal, and to us, 3 radical 2 doesn't really seem like it should be the same thing because we see the 3 and the 2, but when we type this in our calculator, we see that that decimal is the same. All right, that doesn't mean that it's all the way simplified, but at least we know we didn't mess anything up. Okay, I'll show you a different method. Some teachers talk about breaking out of radical jail. It sounds really intense and exciting, but we do a prime factor tree. So I think of two numbers that go into 45. Maybe I think of 3 and 15. You could have also thought of 9 and 5. 3 is a prime number. 15 is not, so I can break that down even more. What's a prime number, you ask? A prime number is a number that's only divisible by 1 in itself, or it doesn't have any other factors. Okay, so at the end of this, we want to use each piece that's the end of like a branch of the tree. So I could rewrite this under the radical as 3 times 3 times 5. And what a radical is looking for is if I'm taking the square root of something, it wants an identical pair. The way we taught it was 1 breaks out and 1 doesn't make it. So at the end, we would equal 3 radical 5. Okay, if I started that process the same way that we did the first problem, the biggest perfect square that goes into this is 9. 9 goes into it 5 times. The square root of 9 is 3, radical 5. Okay, and when we do the square root, the radical goes away. If I was doing the first problem with radical jail, maybe I used 6 and 3. 6 breaks into 3 and 2. So I have a 3, and a 2, where the 3's pair up, 1 breaks out, 1 doesn't make it. Okay, but sitting there and saying, I don't know how to do this, and not using your calculator to check it is wrong. So please try and not do that. All right, so I'd love you to pause for the video, see if you can use either method. Try doing the prime factorization tree, or try figuring out what's the biggest perfect square that goes into 75. So please pause the video and try that. Really, pause the video. Pause. All right, so either way that you do this, okay, I tried to show you with taking out the biggest perfect square, 25, or breaking it into its prime factors, which are 5, 5, and 3. Either way, I end up with 5 radical 3. I know this may seem tedious to type something in your calculator, but if you ever want to know if it's right, you type them both in your calculator and determine, do they give me the same decimal? Okay, so both of them give me this 8.66 decimal. Therefore, this is 5 radical 3. All right, and then in the last example, you might see that 2 in front. And that begs the question, do I add 2? Do I subtract 2? Do I multiply by 2? Do I divide by 2? Or do I just ignore everything and don't do anything with the 2? It's probably your worst option. If something's written next to each other, this would be 2 times radical 32. All right, so at the end of this problem, whatever breaks out of the radical or whatever perfect square I can get out of the radical is going to be multiplied by 2. So I'd love for you to pause the video and try and break apart radical 32, please. Pause. All right, so here we go. Some of these can be a little tricky. The biggest perfect square that goes into 32 is 16, which produces 4 radical 2. If I use the prime factorization method, I keep breaking the numbers apart until I have prime numbers, and I end up with 2, 2, 2, 2, 2. Ballerinas might be excited about that. You might be like, holy twos. But regardless, I had one pair break out, which I did in blue, another pair break out, which I did in green, and when they break out, they multiply together. So these would end up being a 4. I'm left with 1, 2 that sticks underneath that didn't have a pair. And at the end, 2 times 4 is 8 radical 2. Okay, and that's probably as complicated as it can get, besides having bigger numbers. And again, we can double check with our calculator. Okay, so simplifying a radical is really just breaking it down and pairing up identical factors, or it's finding the biggest perfect square that goes into a number. So why are we doing that? In the study of geometry, we may run across a right triangle, or 2, or 3, or in every unit there's a right triangle, and you need to know how to do this. You'll notice in the directions, it says leave your answer in simplest radical form. This is called the exact answer when you have a radical. I know we've been typing in our calculator that have a bunch of decimals. Decimals we would have to approximate because these are technically irrational. What's irrational, you're thinking in your head? Absolutely. Irrational means that it's a number that never ends, it never repeats. Okay, so if we're doing the Pythagorean theorem, first of all, we have to have a right triangle. There are 2 sides that make the right angle. We label them A and B. These are known as the legs of the right triangle. And then C is the side that's across from the right angle. That is known as the, yep, you got it, the hypotenuse. Hypotenuse, perfect. Okay, so you always want to kind of identify that. Sometimes it might be like it looks like the base is the hypotenuse, like in example 1. Okay, but we're finding the missing side. We identify it's a right triangle. We identify side C. We know this is A and this is B, or vice versa. All right, so the Pythagorean theorem is A squared plus B squared equals C squared. Don't worry if you have a hard time remembering that. It's on our formula sheet for the Regents exam. So I would do 6 squared plus 11 squared equals C squared. So please pause the video and add 6 squared and 11 squared either in your head, on paper, or with your calculator. Pause time. So some people like to do them separately. Okay, if I was you, I would just type it in my calculator all together. All right, and then I'd want to see, well, there's C squared. I don't want to get C by itself, but I want to try and figure out how do I break that squared off of the C. Okay, you're thinking it, I'm thinking it. If I square root a squared, it goes away. Okay, so I'm just left with C, and then I'd want to determine, okay, can I take the square root of 157? So I can check that in my calculator. No, I can't. So now I'm going to try and figure out, is there a perfect square that goes into it? And I'd like to show you one other trick that goes along with simplifying a radical, especially when it's a bigger number. I'd like you to hit the y equals button with me. Go ahead, y equals. All right, go ahead. Yep, well done. And I'm going to do 157 divided by x. Okay, and last year I hope your teacher showed you this when you were factoring. Now that I have that typed in, again, if I'm going too fast, you can always pause the video and rewind. Reverse. But I'm going to hit second graph. Okay, and then as I go through, I can look to see, are there any numbers that go into 157? Okay, and I've scrolled far enough where I don't see any numbers that go into it. That means 157 is prime. Okay, and that sometimes that happens. You can't break it down. So my final answer right here is going to be C is the square root of 157. If they wanted me to approximate that, I would approximate it. But if it says in simplest radical form, we need to leave it that way. All right, so we're looking at the second one. I'd like you to label the triangle A, B, and C. You're right. This could be A or B. That's the B or A, vice versa. This side has to be my C value. Okay, I have to have that be my hypotenuse, which is across from the right angle. That has to be by itself. So I'm going to do radical 6 squared plus radical 15 squared equals C squared. You can type the left side of the equation in your calculator. This is just going to end up being 21. Similar to what we did before, I would square root both sides. Okay, and the only numbers that go into 21 are 3 and 7. Because those don't pair up, we're just going to leave this as radical 21. That cannot be simplified. Okay, so sometimes they can be simplified and sometimes they cannot. So make this a little bit bigger for you. It looked a little congested there. Right triangle, we see that with this right angle right here. Hypotenuse has to be the value of C. These two could be A or B. Okay, so I'd like you to pause the video, create your equation, figure out which side are we missing. All right, so I added 10 squared and 12 squared. That gave me 244. Absolutely right. We square root both sides. Okay, and again, when the numbers get bigger, I would go to your calculator. I'd go into y equals. I'd put 244 divided by x. Second graph. This is going to give me a list of the values that go into it. Okay, so I've got 2 and 122, 4 and 61, and then that's about it. I could keep scrolling, but I've got a bunch of decimals here. So I would use the 4 and 61 because I know 4 is a perfect square. If you used 2 and 122, you'd break it into another 2 and 61. So then you'd have the 2, and the 61, where one of the 2's would break out. Okay, but this one we can simplify. So if I take out a 4 and a 61, this gives me the square root of 4 is 2 radical 61. And that is in simplest radical form. All right, so up until now, most of the examples we saw, we had the missing side be the hypotenuse. Example 4 has two things that happen. Number 1 is we're missing one of the legs, so we'd call those A and B. And number 2 is that the hypotenuse is 2 radical 3. And when I put this in my calculator, I'm going to want to use parentheses because I don't want to hold that together. Okay, I'm going to pretend like the 2 and the radical 3 are hugging. The parentheses are showing that hug. We're not breaking them apart. If we don't type it in correctly, we could get a wrong answer. So if we were going to set up this equation, I would have 2 squared plus x squared equals 2 radical 3. And I want to put the squared on the outside. Okay, so the attention's in the details right now. I have to type that in with the parentheses. So hopefully we know 2 squared is 4. If you're not a calculator person, I'm going to need to square both of those because they're multiplied together. If you are a calculator person, I have to remember parenthesis 2 square root of 3 over, get out of the parentheses, squared, okay, because that's 12. If I just type it in like this, it doesn't square both parts and it tells me 6, okay? So I want the 12. And then just like we've solved before, if we want to get that x by itself, I see addition, I would subtract 4 from both sides. I see the x squared, I square root it. I think to myself, can I break this apart? If you recognize that's a perfect square, you can go from there. If you want to keep going, realize that this is 2 times 2 times 2. So 1 pairs up and breaks out. So at the end of our problem, x equals 2 radical 2. All right. The last thing that we're going to be asked to do from time to time is to determine whether or not it's a right triangle. Okay, so state if each is a right triangle. You can't just say, yes, it looks like it. That would be like being on a jury and be like, yes, they look guilty when you haven't heard any of the evidence. Okay, so it looks like right there should be the right angle. If that was the right angle, this is C. These two are my legs. Okay, so if it is a right triangle, then it'll satisfy the Pythagorean theorem. What does satisfy mean? Satisfy means if I square the two legs and add them together and it equals the hypotenuse squared, then it's a right triangle. Okay, and again, notice those parentheses, the squared on the outside, very important detail. Okay, so I'd like you to type both sides into your calculator to see if they give you the same thing. All right, so here we go. I typed them both in. 6 squared plus 8 squared gave me 100. 4 radical 5 squared in parentheses gives me 80. Okay, does 100 equal 80? Hoping you're thinking no. That means this is not a right triangle. All right, I'd like you to try number 6. This is where we think the right angle might be. This gives me my A and B being the 19 and the 14. C is radical 421. So I want to know, does 19 squared plus 14 squared equal radical 421 squared? And both of those give me a different value. I'm not sure if that's what I wanted to have happen. We have 557. Okay, so this is also not a right triangle. All right, so if they did equal each other, it would be a right triangle. I really appreciate if you got through all of this video. I hope it wasn't too tedious. You know, I would flip this over right now and get the homework done, but we'll be using both of these skills a lot throughout the rest of this year. Don't forget to hit subscribe, notifications, like, leave a comment if you want. I'm just really trying to improve geometry and math and your life, having that in it one day at a time. Have a great day.